Hello. In this presentation I will talk about Hue primarily. It's part of systems for specifying color known as either HSL or HSV. So Hue is a method of specifying color. It's firmly rooted in the RGB scale, so it's really in terms of ratios of the colors of red, green, and blue modulo the amount of white that's present in the light. It's part of a couple systems. There's HSL, hue, saturation, luminance, and so saturation, this measures how pure the light is. Luminance measures the overall brightness of the light. So let me just mention those very briefly. To compute luminance and saturation, we use the methods as follows. So we're given RGB values for color. We let min equal the minimum value of red, green, and blue, and we'll let max equal the maximum value of red, green, and blue. And then luminance can just be defined to be the minimum value plus the maximum value over 2. And this is meant to measure the overall brightness of the light. Now, it's by no means a perfect measurement because it ignores the middle color. And so it doesn't really measure the brightness all that accurately. But it does give a measurement, and it does keep the value in the range 0, 1 if R, G, and B are all in the range 0, 1, and L is in the range 0, 1, with maximum value at 1 and minimum value at 0, of course. Saturation is a measure of how pure the light is. So it's done in terms of whether the light has any white component. As a component of white light. So white, or gray, would be with red equals green equals blue. There'd be no color per se. It would just be a white or gray with red equals green equals blue. So if R equals G equals B, then the saturation is 0 because there's no actual color. It's just a gray or a white or black. If the minimum value is equal to 0, then the saturation is 1. There's no component of whiteness in the color at all. And in other cases, I'm just not going to give you the formula, but in other cases, S takes on intermediate values. And the idea being that the more white you have in the color, the lower S is. The less white you have in the color, the higher S is. And that's taken up by, at the extreme ends, are these two conditions here. And otherwise, there's a somewhat strange formula for S in the middle level that I'm not going to show you on the whiteboard. You can see it in the textbook if you're interested. And this leaves the main topic, which is, what is hue? So hue measures color in terms of angles around a wheel or a circle. So we form the following sort of image. Here we've got a circle, and we put red here. Here, I'll get fancy with some colors here. So red is here at the angle of 0 degrees. Here's 120 degrees. Here's 240 degrees. And we'll have some intermediate angles, 60 degrees and 180 degrees and 300 degrees. And the colors we're going to attach here, first of all, we'll put primary colors, green at the multiples of 120, and blue at 240. And then we'll put the remaining colors of yellow. I do not have a yellow marker, so I'm going to use this sort of orangish marker instead for yellow. I don't have a cyan marker at all, so I'll just use black for cyan. And I really don't have a magenta marker either, but I'll use this color for magenta. And we measure the color as follows. You think of starting off with pure red without any green or blue. As you go around the circle, you start mixing green in. When you get to equal green and red, you have yellow. When you get all the way to green, you have just green, no red or blue. Cyan is where you have 50-50 green and blue. Here's pure blue. And magenta is where you have 50-50 blue and red. So this is based very much on the RGB additive color system, but it gives a way of going around the wheel. Let me take a short break for the computer screen, and we can see this in the proper colors. So in this image, we see the circle of colors again, starting at red at angle 0, hue equals 0, gradually transitioning to yellow at 60, to green at 120, to cyan at 180, to blue at 240, to magenta at 300, and then back to red at 0. And we're back. So I'm going to now give you an algorithm for hue. We're going to compute the hue value from the red, green, blue values. So the inputs are RGB values. We think of them in the range 0, 1, and the algorithm is the following. First, we set max equal to the maximum of RGB, and we'll set min equal to the minimum value of RGB. And we'll set delta to be the difference between the max and the min. So delta is max minus min. And if delta equals 0, we'll just set hue equal to 0. The color is just a gray or black or white. And so we'll just default to hue equal to 0 in that case. Otherwise, we'll compute hue as follows. So first of all, if R is the max value, that puts us over on the side of the color circle between 300 degrees and 60 degrees. Then we'll set H equal to 60 degrees times G minus B divided by delta. If this gives a negative value, if H is less than 0, we'll set H equal to H plus 360 degrees to bring it back positive and make always the hue in the range 0 to 360. Else, if green is the maximum value, then we'll set H equal to 120 degrees plus 60 times blue minus red over delta. Otherwise, in this case, we'll have that blue is the maximum value. we'll set H equals to 240 degrees, that's centering us around 240, plus 60 degrees times R minus G divided by delta. And we have an end if here and an end if here to close off the two loops. And this is the calculation of hue. So to understand how this works, let's just do the first one here where the maximum is red. If the maximum is red, we're going to be in this range of the color circle, somewhere between negative 60 degrees, positive 60 degrees, or when we wrap things to be positive, between 300 degrees, so 60 degrees. And in this case, so with R equal to the max value, let's also suppose that blue is the minimum value, and that'll put us in this range here between 0 and 60 degrees. And then we have that delta is R minus B, of course. And then G minus B divided by R minus B is supposed to give us the fraction of the way we're going from 0 degrees to 60 degrees. The fraction of how far we are from 0 degrees to 60 degrees. So the idea being that if G minus B is 0, then the color is red, strictly red, plus equal amounts of red, green, and blue under that. And so the dominant color is red, and the green and blue are exactly the same value, so the color looks red there. As the fraction of green increases with G minus B increasing, once G minus B is equal to R minus B, then we have equal amounts of green and red, and so we're at 60 degrees. So this explains, at least for 1/6 of the circle, how these formulas work. The other parts all work the same. The 120 degrees plus and the 240 degrees plus just serves to center us around the green and the blue, and otherwise the idea behind the calculation is exactly the same. So hue is often used as a way to specify colors when you're trying to do a user-friendly way to specify colors. A lot of programs, such as word processing programs, paint programs, and so on, will let you select a color either by setting red, green, blue values or by picking hue, saturation values, and so forth. So the hue is meant to give a more intuitive way to specify color by thinking about going around this circle. And this is one of the common ways for it to be computed. That's the end of this presentation. Thank you very much.